All right, we're talking about prime factorization and prime and factoring numbers and finding, the last video talks about finding the greatest common factor. Here's our greatest common factor. That's what we're going to work with. So there's factors and products. Factors multiply together to get a product. We're going to go up here. We're going to fast forward here. We talked about the cake method. We talked about finding the least common multiple of previous examples. But today, in this video, we're talking about greatest common factor. And we're going to find the cake method is going to be pretty helpful. We're going to find the greatest common factor here. What's the greatest common factor? What's the factor that can be pulled out of, can be divided into each of two or more numbers? That's the greatest number that divides evenly into all those numbers. That's the greatest common factor. We're going to use the cake method to find the greatest common factor, and incidentally, we're going to find something else as well. So what's the greatest common factor of 6 and 30? Well, here's an example. You know what? I'm going to put 6 over here. I'm going to use 30 over here. I'm going to say the cake method. Again, we'll put a layer of cake. It's going to be an upside down cake, so just bear with me, I suppose. But again, we're going to see we've got 6 and 30 inside the cake, inside a layer of cake. And we're going to pull out the greatest common factor. We're going to pull out a common factor between 6 and 30. What's between 6 and 30? What factor goes evenly into 6 and 30? 6 is even, 30 is even. We start with 2, so let's start with 2. Pull out a 2. 6 divided by 2 is 3. 2 is a factor of 6 because it divides evenly into it. 30 divided by 2 is 15. Sure enough. So 2 is a factor of both of them. Is there a common factor between 3 and 15? Sure enough. Add another layer of cake and say it's not 2 anymore because 2 does not go into 3, but 3 goes into 3. And 3 goes into 15. So we can say now that 3 divided by 3 is 1. We're going to again pull out these common factors over here. 15 divided by 3 gives me 5. So we're going to find that over here, these numbers that we pull out, greatest common factor equals 2 times 3 equals 6. Sure enough, it could have jumped out at us. Probably did jump out at us. But we're also going to find that if we make an L with all this information, right there, make an L, that L is going to give us the lowest common multiple, least common multiple, or least common denominator later on. But least common multiple of 6 and 30 is 2 times 3 times 1 times 5. Just list all those factors that are out here. We can ignore the 1, but I put it here just because it's, it's kind of a place marker. 2 times 3 is 6 times 5 is 30. Least common multiple of 6 and 30, 30. Greatest common factor of 6 and 30, 2 times 3, 6, because it's in the red. Let's make a little bit more space here and say what's our greatest common factor of 42 and 63. I'm going to say take a time out here, use the pause button, and find the greatest common factor between, also I suppose, find the lowest common denominator as well of both of those, or lowest common multiple. I suppose lowest common multiple is what we're talking about. Sorry, least common multiple. Find both of those, least common multiple and greatest common factor, using the cake method. Alright, if we're doing it, we're going to use the cake method. 42, 63, layer of cake here. Well, let's see. I'm going to start with 2. Is 2, because 2 is a prime number. 2 goes into 43. 2 does not go into 63. Alright, we can't pull out a 2 as a common factor here, or a factor here. 3, does 3 go into 63 or 42? 4 plus 2 is 6. 3 goes into 6, so 3 goes into 42. 6 plus 3 is 9. 3 goes into 9, so therefore 3 goes into 63, so we can pull out a 63. Sorry, we can pull out a 3 out of each one of those. 3 goes into 42, 1, 4 times. 3 goes into 63, 2, 1, 21 times. 63 divided by 3 is 21. 42 divided by 3 is 14. That's how the cake method works. Now let's see if we can pull anything more out. Between 14 and 21, we pulled out a 2 already, or we determined we couldn't pull out a 2. Could not pull out a 2, so therefore we moved to 3, pulled out a 3, divided each by 3, and now is there another 3 in here? 1 plus 4 is 5. Nope. So we go to the next one. 5. 5 does not go into 14 because 4 is not a 0 or a 5, so we go to the next prime number, 7. Is 7 and 14 and 21? If you follow football, sure enough, you know that there's a 7 and 14 and 21. Two good numbers for the office pool. 14 divided by 7 is 2. 21 divided by 7, 3. 2 and 3 are both prime. They don't share any common numbers. So, therefore, we're now done with our cake method, and we can say that right here, greatest common factor equals 3 times 7 equals 21. That's our greatest common factor. Lowest common multiple, we use our L here to say my lowest common multiple is 3 times 7 times 2 times 3 equals lowest common multiple 21 times 6, let's see, 126. 3 times 7 times 2 times 3 equals 126. I'm going to be sure about that one. 126, lowest common multiple is 126 because of the L over here. The green is over here, the kind of the icing on the cake is our lowest common, or sorry, our greatest common factor. Greatest common factor 21, lowest common multiple 126.